चैनल को सब्सक्राइब कीजिए और बेल आइकन को दबाइए लेटेस्ट इंफॉर्मेटिव वीडियोस सबसे पहले देखने के लिए।
A deflection of any structure must be limited during its lateral movement for a number of reasons, and hence provision of adequate stiffness is also that much important. If you have questions like what is relative deflection, that is horizontal, that is simply known as a story drift, how to take it into consideration, what are the specified limits for that, what is important to be within limit, what happen if it is out of limit, etc, etc, then to get the answers of this all, please remain with this video till the end. Generally, a drift is defined as a lateral displacement. But to design any structure, it is very important for a designer to understand the difference between lateral story drift and interstory drift. Now let's first talk about the lateral story drift. It is the amount of side sway between two adjacent stories of a building caused by lateral loads, wind, and the seismic. If you look at to this figure, a four-story building is deflected at its different floors with increasing amount of deflection, that is D1, D2, D3 and D4. For a single story building, here if we consider only ground story, the lateral drift equals to the amount of horizontal roof displacement, and that is equal to D1. And to get the story drift at third floor level, deflection of third floor is deducted from the deflection of below floors, means floor, that is second floor. So by equation it would be D3 minus D2. Now if we talk about the interstory drift, it is the difference between the roof and floor displacements of any given story as a building sway in during the earthquake, normalized by the story height. For an example, if we take for a 10 feet high story an interstory drift of 0.10 indicates that the roof is displaced 1 foot in relation to the floor below. Interstory drift is one of the particularly useful engineering response quantity and indicator of a structural performance, especially for high-rise buildings. However, many researchers and engineers do not notice the difference between interstory drift and harmful interstory drift. Also, few programmers have considered the harmful interstory drift in their structural analysis procedure. So they may unreasonably use the interstory drift as unique standard for structural behavior judgment, which may eventually lead to unacceptable results and relatively conservative conclusions. This is because non-structural elements such as claddings, partitions, and pipework must be able to accept the deflection imposed on them during an earthquake without any type of failure. Failure of external cladding, blockage of escape routes by fallen partitions, and ruptured firewater pipework all have serious safety implications. However, in some of the columns in a building may, if we see that it is only be designed to resist gravity loads with the seismic loads taken by other elements. But if deflections are too great, they will fail through P-delta effects, however ductile they are. Overall deflections must also be limited to prevent impact both across separation joints within a building and between buildings. The low stiffness of moment resisting frames tends to cause high story drift, that is known as interstory deflections, which may lead to a number of problems. This includes unacceptable damage to cladding and other non-structural elements, and to other serious structural problems. Moreover, the width of separation joints within the structure may need to be large to prevent buffeting during an earthquake. And this can lead to a problem in detailing and acoustic, thermal as well as weather tight bridge to cross joints. A more general problem with the flexibility of moment frames, particularly in tall buildings, is that design may be governed by deflection rather than strength, leading to an efficient use of material. Story drifts, that is generally the difference in horizontal deflection between the top and bottom of any story, must be checked and compared with specified limits in standard codes, principally to limit damage to non-structural elements. As per the Indian standard IS 1893-2002, clause number 7.11.1, the story drift in any story due to the minimum specified design lateral force with partial load factor of 1 shall not exceed 0.004 times the story height for the purposes of displacement requirements only. There shall be no drift limit for single story building which has been designed to accommodate story drift. Now, if we talk about P delta effects and separations between structures to prevent pounding must also be checked. Specific elements such as external cladding and columns sized for vertical loads but not seismically detailed must also be checked to confirm that they can withstand the deflections imposed on them during design earthquake or not. The greater the drift, the greater the likelihood of damage. Peak interstory drift values larger than 0.06 indicates severe damage, while values larger than 0.025 indicate that the damage could be serious enough to pose a serious threat to human safety. Values in excess of 0.1 indicates probable building collapse. With this, hope you understand the effect of story drift in building during earthquake and its remedial measures. So stay with this channel for more videos like this, and if you have any questions or suggestions, please use comment box.